So here at ECOC again, I'm talking to Stephen Adolph, VP of Marketing for the Coherent line of DSPs like Orion. Yep. And my question is, I always ask is, what's going on here?
Well, here at the demo here at ECOC, we're showcasing the Orion DSP, which is our current generation 800G Coherent DSP.
Okay.
In the demo, we're showing that the DSP supports multiple transmission modes. And the purpose behind that is to show people that the DSP is not only capable of 800G transmission at short distances and long distances, but also capable of transmitting data at 600G and 400G. So we have a menu here which allows us to display different constellations and different transmission modes for these different reaches.
What would be the different modes? Like what would a telco or a cloud use one mode versus another mode?
Well, if the network operator was really interested in getting the maximum performance on a short distance of fiber, they would use the 800G mode. So they would use what's being shown here, which is a 16-QAM constellation, to push as much data to the fiber as possible. But if they're interested in connecting data centers that were up to, say, 2,000 kilometers apart, they would operate the Orion DSP at 400 gigabits per second using a QPSK modulation spec. And that would extend that distance out to 4,000 kilometers or more.
Okay, wow, amazing. The one thing I always love about Coherent is the history of it. Like you explained in Smart, the technology originally was for subsea cables.
That's right. Way back in the early days of optical transmission, everyone always sent data using what's called on-off keying. So the laser was on and it was a 1, or the laser was off and it was a 0. Pretty straightforward. Right. And that held true all the way up to the roughly 2010 timeframe. But the problem with that kind of transmission approach is that it suffers from distance impairment. So companies in that space were hitting brick walls in terms of performance. So
really, like go a certain distance and then it would just put static after that, or
that's right. Which says the signal simply would not propagate and be recoverable on long distance. So the industry needed a technology solution, in-step coherent transmission. And coherent transmission is a lot like FM radio compared to AM radio, which is like on-off keying. And it turns out that using these coherent methodologies in the submarine industry, they use coherent technology to really extend signals across the Pacific Ocean and the Atlantic Ocean. So it was really a super technology for addressing long distance there. But what we're showing now is as the speeds keep increasing, these distance penalties are just harder and harder to overcome. That's where coherent plays in. Okay. So we still see on-off keying is used for PAM4 type signaling. So the same sort of approach, turning the laser on and off at different amplitudes. That still has use today inside the data center. But increasingly, coherent technology is moving from this very long-haul regime of submarine into the carrier long-haul, into regional metro, now strongly in data center interconnect, and closer into the data center reaches as well. So we see it being important for 10 and 20 kilometer reaches as well.
So it's going longer, like getting all the distances the old embedded equipment used to do, but also getting those shorter distances like campuses and things like that.
That's right. And you know, they need to do different things at these different reaches. So for the very long distance solutions, you need very high performance stuff. For the inside the data center and closer to the data center applications, you need lower cost and lower power. So coherent technology, like what we're showing here with Orion, has that flexibility to go from the high performance end and also the low power short distance market as well.
Excellent. Thank you very much.